All right, so hopefully you gain some insight into what the scale factor or the A term represents in order of these quadratics, in terms of these quadratics. Everything that we have been doing up to this point has had an A term or a scale factor of 1 or a negative 1. Those are the two options we've been exploring so far. But from here on, we're going to explore different numbers like 3, 4, 9, or 1/3, which is kind of hidden here. We will come back to this problem later. But that's the main idea. Hopefully you can identify that these have a vertical scale attached to these equations. Even though we won't be graphing them, they're going to be very prevalent in the next few lessons. So let's get started. How do we solve something like something squared or n squared equals 16 before? We said that n either a positive or a negative 4. And hope you should feel very comfortable solving those type equations from like the first or second video. Otherwise, go back. But look, here we don't have n squared. We have 3 times n squared. We want to undo the 3 times something. How do we undo multiplying by 3? We're going to divide both sides by 3 so that we get an n squared on the left side. 48 divided by 3. This is 16, so n is either positive or negative 4. Notice how we turned this equation into that equation. Gave us the both same set of solutions. All right, now we have a 4 times something squared. The main idea is we have something squared for all of these, so we just need to undo the multiplying by 4. And then we have 100 divided by 4 on the left side. It gives us a 25. And 4 divided by 4 is just 1k squared. So therefore, we know that k is either a positive or a negative 5. That's simple, but only if you know what to do. Oh, I love this problem. Check out what happens right here. Same type of idea. We want to undo the positive 16. And we are going to undo that on both sides, especially since we have a 0 here. That's the key part. We're going to have a negative x squared equal to a negative. I'm sorry, 9x squared equal to a negative 16. I was already thinking about the negative. Look at that. You might even stop here if you don't see it yet. But otherwise, you're going to think, how do we undo the multiplying by 9? We're going to write that something squared equals a negative 16 over 9. And think to yourself, can we ever square a positive or negative number and get a negative fraction or a negative number in return? And we said for this case, there's no real solution. And I'm glad to revisit this because we're going to talk about what type of solutions does it have in the future. For right now, we will say no real solution because something squared can only be positive. And look at how this equation almost looks identical to what's going on right here, with the exception of the negative 16 and positive 16. Let's see how those subtle differences make an impact on the solution. So we will say that 9x squared. How do we undo subtracting 16? We're going to add 16 on both sides and get 9x squared equals 16. And again, we want to undo multiplying by 9. So we will say that x squared equals a 16 over 9. And now because this is a positive y or positive value, we could have two solutions. X is either a positive or negative. The square root of the numerator is 4. The square root of the denominator is 3. So positive or negative 4/3 or 4 over 3. As opposed to no real solutions from before. All right. This is the last time we will be seeing a problem with, I think the last time, with 9 minus something squared, meaning that the a term is either a positive or negative 1. And the nice thing, because this is 0, I just wanted to remind you of that. We're going to add m squared to both sides just to make it a little bit simpler. So this is 9 equals m squared, which means that positive or negative 3 are the two numbers that we can square to get a 9. And this is a more advanced version of it. But don't get fooled the fact that the 0 is on the left side, because we will see that very often. We still have negative something squared. Even though it says negative 3, still think about it as negative something squared. Let's add that to both sides so that we can write 3m squared on the left side equals positive 27. Notice how that it makes a more efficient equation. And then we ask ourselves, how do we undo multiplying by 3? We're going to divide both sides by 3 so that we get m squared on the left side. 3 divided by 3 is 1. And 27 divided by 3 is 9. Therefore, we know m is either a positive or a negative 3. Look at that. how efficiently we're able to solve these type of complicated looking equations. This right here has the same solution as that one. Notice that. Okay. And this is what we're going to be dealing with the most often. So still think about it as negative something squared on the left side equal to 0 on the right side. Therefore, we can add that quantity. 80 equals positive 5t squared. We're adding 5t squared to both sides. And we have to undo now multiplying by this 5. What's the opposite of multiplying by 5? Divide both sides by 5. So 80 divided by 5 is 16. And then on the right side, we're left with the t squared. 5 divided by 5 is this 1 that's invisible here. Therefore, we know that t equals either a positive or negative 4. I want to say a word about this in this case. Because t in the future will most likely stand for time, you have to ask yourself, can t be positive 4? Can time be positive? And the answer is yes. But can time be something like negative 1 or negative 4 or negative 2? Can time be negative? Absolutely not. So just keep that in mind. All right, we're almost there, and then it gets more advanced. But what I want to point out is all of these equations that we solved, we didn't do any factoring. This is all solved by perfect squares, which I want to point out. There's two types of approaches that we take to solving quadratic equations up to this point. Number one is a perfect example of perfect squares. All of these are perfect squares, and we're still going to come back to this. But notice that on 1b, they get more advanced. Even though still a perfect square, they get more advanced because not only do they have a vertical scale, they have some vertical shift, all right? And sometimes they don't, but let's see what happens. All right, so we have 2 times something square equals 50. We want to undo multiplying by 2, and we just want to isolate the something square. How do we undo multiplying by 2? Let's divide both sides by 2. So on the left side, we're remaining with x minus 4, or something square equals 50 divided by 2 is 25. And this is much easier to solve now. So we can say that x equals, or x minus 4 equals plus or minus 5. That was the slow way of doing it, but we haven't shown this work in a long time, so it's okay. And now we want to ask ourselves, how do we undo this subtracting 4 on both sides? We're going to add, so positive 4 plus or minus 5. And now we can say that x equals, we have 2 solutions, 4 plus 5, which is a 9. Or x equals 4 minus 5, which is negative 1. And boom, look at that. Perfect squares with a little bit more work to show, but we've been working with this for a long time. We have 12 minus something squared equal to 0. Let's undo this minus something squared. How do we undo that? Let's add it to both sides. So we get a positive 3 times something squared equal to 12. The something is still x plus 5. And now we need to undo the 3 times something. How do we undo multiplying by 3? Let's divide both sides by 3. So 12 divided by 3 will be a 4 equal to something squared. The something is still x plus 5. And we arrive where we wanted to. This is very easy from here. We have something squared equals 4. What 2 numbers did we square to get a 4? It was a positive or a negative 2. And the something is still x minus 5. Because we haven't shown that type of work in a long time, we have one more step. We want to undo the minus 5. We will do that by adding 5 to both sides. So 5 plus or minus 2 is equal to x. So therefore we know that x equals a 5 plus 2 is 7. Or x equals 5 minus 2, which is 3. And that one's done. So that idea of perfect squares is still very powerful, but you need to train your eyes how to undo this times 3, how to undo this times 2. And now it's something different. How do we undo this 1 over 9? Even though we don't start here, we still start with this minus 4. So the a term is 1 over 9. Now it's less than 1. But let's still undo the minus 4. We're going to add 4 to both sides so that we get 4 equals 1 over 9 times something square. The something is still x minus 3. And when you get fractions like this and you get intimidated, ask yourself, What does this mean? This means we're multiplying by 1 and dividing by 9. So we only need to focus on the dividing by 9 part first. How do we undo dividing by 9? By multiplying both sides of the equation by 9. And if you need to think about it, for 1 over 9 times 9, you can even say 9 over 1. If you don't, then just write it as 9. And 9 times 4 is 36 for the left side. Is equal to, and the reason why I wrote 9 over 1 is because 9 over 1 times 1 over 9 is just 1. Or it gives us 1 times something squared. The something is still x minus 3. And now we're at a place that we're really comfortable. This was the hardest part. This is very simple from here. We know that to square a number to get 36, it better be a positive or negative 6. And the something is x minus 3. Therefore, we only need to undo the minus 3 part. So add 3 to both sides, plus or minus 6 equal to x. And remember that we added 3 to both sides of the equation. So now we can say that x either is equal to a 9 or x equal to a negative 3. Let me rewrite that. There we go. And again, if you're having trouble with that, take your time to verify that, because that should be correct. I'm going to double check right now, just in case. 3 plus 6 is 9, and 3 minus 6 is negative 3. There we go. That's how you check. Doesn't take more than that. And again, remember that problem number 1 was all perfect squares. That's usually the one that's less common, but the most powerful in this course. The one that you're going to see more often is solved by factoring. And you should notice things like GCF, greatest common factor. And if that doesn't work, most of the time it will show up. But if that doesn't work, just ask yourself, oh, I know it's the product and sum property of factoring, okay? So let's find out. This first two only had 2 terms. But I'm going to ask myself, is there anything in common, like a greatest common factor? And the answer is yes. They both have a 6 in common. And not only that, they at least have an x term in common. So we're going to say the greatest common factor is 6x times something equals 0. And take your time with this, but this should be x plus 4. If you have questions about that, ask somebody in the comments or ask your tutor. And then we know that 6 times something equals 0. The x better be equal to 0, or the something. And then what makes this something equal to 0 when x is negative 4. Those are the 2 solutions for this type of quadratic equation by factoring. Pretty easy, right? But some of the times the coefficients won't be a common term, except you will notice this are negative something squares. When that's the case, we can factor that one out. So we're going to say negative, and there's both of the terms have x attached to it. So we can say negative x is the GCF. And inside, we should get a positive x. Think of it like this. What's the opposite of a negative value? It better be a positive x. What's the opposite of a positive? It better be a negative 9. And then therefore we have factored it. Therefore we can say that either x equals 0 or x equals 9. You can double check and verify those are true. Cool. You know what I'm saying? But then they're not as boring as this usually. They have an a term or a stretch factor attached to it like this. So let's see what happens when that's the case. Especially if you see a negative, still factor that out as long as the GCF. So it's negative 3x now times x minus 7. And notice how this is very easy to solve now. We can say that either x equals a 0 or x equals 7. Boom. Look at that. That's the power of factoring. Before looking to do a perfect square idea, even though this is what I did first, is because it's more important and it's harder to master. This is more powerful. If you can factor, there's no reason why you should be doing something else. Factoring should be our number 1 favorite and go-to method, because some of them get this complicated. Look at that, man. There's a lot more going on here. But again, look for factoring, and that's going to be the fastest way. What do all 3 of these terms have in common? Be very careful. Do they have the variable x in common? Look at this 48. The answer is no, so only a 2. So now we can say 0 equals 2 times something. And that something is going to be x squared minus 2x. You take your time and verify this, minus 24. But like I said, this is powerful because now we can ask ourselves, can we factor what was inside the something, meaning this expression here? Notice how there's no more GCF. But then the idea is, what are the two numbers that have a product of negative 24? They can multiply to this, but combine to a negative 2. We know for x squared, it was x times x. That's no issue. But then the two numbers are some form of 6 and 4. And because this is negative 2, there better be x minus 6 and positive 4. But then again, we're not done here. You can always double check this. This checks for sure. The solutions are going to be x equals 6 or x equals 4. And done. This is way easier than making a perfect square, trust. And then when we really are going to be applying this is in word problems involving t or time. So let's see what that would look like. All right, again, not only is in the negative 3 that or 3 that they have in common, there's a negative. So we're going to say negative 3 times something equal to 0. And you check your own work, okay? But the way I think about it is, what's the opposite of a negative? It better be a t squared. What's the opposite of a positive? It better be a negative 3. What's the opposite of a positive? Better be a negative. What's the opposite of a positive? It better be a negative 10. And you can check with the derivative property, but I've done that already in my head a few times. So I know that now I can think, can this be written as 3 times something times something? All right. And we think product is negative 10. The two numbers multiply to negative 10, but those same two numbers combine to 3, only if we have negative 5 and positive 2. Check your work. That definitely checks. So we can say that t equals 5 or t equals negative 2. And again, if this was a word problem, think of which of these two answers would not make sense. Can time be positive 5? Yes. Can time be negative 2? No way. Time cannot be negative any value. All right. That's the main idea. All right. These two were nice because both of the problems before on 2b were equal to 0 somehow or another. But this is not equal to 0. So then the question is, what do we do when that's the case? Well, then you make it look like this. So meaning we want to undo this positive 15. The left side's almost going to remain intact. 5t squared doesn't change. Minus 30t doesn't change. But now we have positive 50 minus 15, which are like terms. So we are left with positive 35 equal to 0. So notice how by subtracting 15 on both sides of the equation, we turn this type of problem now into one of these. And from here, we shouldn't have any problems. I hope not. We can factor out a negative 5 and say that the something is t squared. Check your work. The opposite of a negative is positive 6 t, and the opposite of a positive is negative 7. There we go. Can we factor what's inside? We will be remaining with negative 5 times something equals 0. And the product is negative 7. The sum is 6. Therefore, we know that t times t is the easiest part for this t squared component. And we're thinking of some form of 7 and 1. And that only works if the 7 is positive, so that we get a positive 7 minus 1 is 6. And positive 7 times negative 1 is negative 7. That definitely works. So now we can write that. The t values are a negative 7 or t equals 1. But again, if this was in the context of a word problem, we would definitely scratch that one out, okay? Because time cannot be negative. However, since it's not that's not the case, we will leave it as is. All right, not bad. This is the type of equations that we've been solving before. We're adding the extra component of the A term or the vertical scale. If you have any questions, you're confused, go back to previous videos and polish your skills. Other than that, I don't know why you still would be listening to me. You can either still listen to some more math problems, and I forgot that I didn't do this one. So if you're still stuck around, good news for you. Let's do this one very quick. So we undo the minus 2. We're going to write that x squared over 3. And think of it like only the x part is being squared, not the 3 component. And now because we're adding 2 to both sides, we're going to get a 12. We're going to take this work here. We want to undo, this means something divided by 3. How do we undo something divided by 3? By multiplying both sides of the equation. If you need to show it, oh, I don't love it, but let's show that we're multiplying both sides by 3 so that we get x squared on the left side. equals 36. And that's not too bad. That's x equals plus or minus 6 and done. So that if you stuck around, you didn't waste that much time. But if you're confused, go practice other stuff. Otherwise, I'll see you in the next few videos. These ideas with the stretch factor and a term will show up in a lot of word problems. So if you don't understand that, I recommend that you stick right here. Don't move forward. All right. So have a good rest of your day. Go skate. Go for a hike. Go for a walk. Do whatever you like. But stop listening to me now, unless you're listening to me talk about more math problems. So see you later in the next few videos, or hear me in the next few videos. Bye.